Okay, so in this little discussion, I'm going to talk about the process of DNA replication. If you remember from our notes, DNA is made up of monomers or building blocks called nucleotides. And in the nucleotides, there are nitrogen bases that are at the center point that are connected by a weak hydrogen bond. If you'll recall, this hydrogen bond needs to be weak because it's always being broken and always being put back together to pair up the bases. Put an A in there and a T in there. So what is it that happens when DNA has to make a copy of itself? Well, we're always used to seeing the double helix look something like this. And we know that there are 5 base pairs between each one of these twists. So in order to copy this DNA, which eventually means we're copying a chromosome, we've got to first unzip this DNA strand in order to access these nitrogen bases. It's these bases that we need to make a copy of. So what first happens is there's an enzyme that is called helicase. If you recall from your notes, what helicase does is it picks many, many locations amongst the double helix to go through and open up the actual molecule of DNA. And so for my example here, I'm going to show that part of the DNA is still wrapped up as DNA, but there is a section of it here that has been opened up by the helicase enzyme. And for the purpose of time, I'm not going to draw the alternating sugars and phosphates that are along the side, but I will put down what the nitrogen bases are. So I'm going to randomly make these up. Although in real life, these are not random. These actually have a code that is necessary in order to build proteins. So now that I've made these, I have TAC, GAT, ACT, which means on the other side, when I open this up, this must be A, T, G, C, T, A, T, G, A. And I know it needs to be this because of the base pairing rule for DNA that says that A to T and C always goes with G. So what happens next is another enzyme that is called DNA polymerase. It is now used to go off and find free-floating nucleotides that are going to be brought in to pair up with these unpaired nucleotides. And remember, a nucleotide looks like this. I'm going to choose the letter T to put in this one for thymine. So this nucleotide could be brought in by the enzyme to pair up perhaps with this A right here. And all these enzymes, these DNA polymerase enzymes, they end up pairing up. Every single one of these opened up DNA molecules. And what you end up getting is a brand new strand over here. The same happens over here. Again, these are held together by weak hydrogen bonds. And I end up with 2 new strands of DNA. This is called a semi-conservative process because in each one of the new strands that I'm making, there is a piece of the original strand, meaning this piece over here is original and this piece over here is original.